Hello students, in this video today we are going to study oxidation and reduction reaction, which together called redox reaction. So let's see. Oxidation and reduction, together it is called redox reaction. Redox, it is made up of two words, R-E-D, it means reduction. OX, it means oxidation. Fine. So, what is oxidation? Oxidation means removal of electron. Second, addition of oxygen, and the third way in which we can explain oxidation is the removal of hydrogen. This is oxidation. Now we will see reduction. Reduction is very easy to learn, that all the definitions are just opposite of oxidation. This removal of electron, so here it will come addition of electron. Second, addition of oxygen, so what will come here? Removal of oxygen. And the third one, here the removal of hydrogen, so what will come here? Addition of hydrogen. So first, this must be clear to all of you, what is oxidation and reduction. Okay, so let me explain this redox term with the help of one experiment. In this experiment, you have to take one glass tube. The glass tube, both the ends of the glass tube are closed with the help of cork. Both the ends of the glass tube are closed with the cork. Okay, fine. So, from one end, that through a fine tube, air is passed, and from the other side, outlet is left for the gases to come out. In this glass tube, you take a spatula or a spoon, and in this spatula, you take copper powder. Okay, so, and heat this tube over the flame or over the burner. So as we are heating this copper and we are passing air through this tube, so what happened? In the air, oxygen is present. So when copper is there, so this copper Cu, it is of red color. Fine, it is of red color. I am passing air over the red hot copper which contains oxygen. So, and some gases comes out also through the other outlet. So, after 10 to 15 minutes, what you will observe, that this red color copper turns to black. This red color copper turns to black. What happened in this reaction? So, actually this copper, it combines with oxygen which has come from air, and it forms CuO. This is what? Copper oxide. This is copper oxide. This copper oxide, it is of black color. It is of black color. So balancing, all of you know. So you have to balance this reaction in this way. 2CuO. Copper oxide, it is of black color. So in this reaction, you can see that here oxygen is added to the copper. Addition of oxygen, and here it forms copper oxide. So this is the example of oxidation. This is the example of oxidation. In the same experiment, I will show you reduction example also. So let's see. Same you take that now this is now no more copper powder. It has turned black after the oxidation. It means that here black color powder is present. Black color powder is present, and this black color powder, it is of copper oxide. Fine. So now instead of air, you pass hydrogen gas through this tube. So as soon as we pass the hydrogen gas through this copper oxide, means over the copper oxide black color powder, so after 10 to 15 minutes, you will observe that this black color copper oxide is converted into red color. So what's the reaction here? Just see the reaction. Copper oxide, hydrogen gas is passed. It is converted into copper and H2O. This is of black color, and now it has turned into red color. So in this reaction, you can see that oxygen is removed. Hydrogen is added. So come to the definition of the reduction. Removal of oxygen. Addition of hydrogen to this. So addition of hydrogen. So here the removal of oxygen, it means that what happens to this copper oxide? Reduction. So this copper oxide is reduced. So I think it's clear to all of you that what is redox reaction. Redox reaction, it is the reaction in which oxidation and reduction takes place simultaneously. The important is that simultaneously, I said that it's not possible in any reaction that only oxidation or only reduction take place. Both these reactions take place simultaneously, oxidation and reduction. So now we will see many more examples of the redox reaction. So in the meanwhile, note down this. I think all of you have noted down this definition of oxidation and reduction. Another example is zinc oxide and carbon. Zinc oxide and carbon, it forms zinc plus carbon. Write down this reaction. Iron oxide and aluminium. It will give you aluminium oxide and iron. Balance the reaction. This. Now in this reaction, you see zinc oxide and carbon. Okay. Now this zinc oxide is converted into zinc. So what happened in this? Removal of oxygen take place. Removal of oxygen is reduction. See carbon. This carbon, as oxygen is removed, so this oxygen is added to carbon and it is converted into carbon monoxide. So here conversion of carbon into carbon monoxide, that is addition of oxygen, is oxidation. Now I think it's clear that why I said that oxidation and reduction takes place simultaneously. So in the reaction, remember, if one substance is reduced, so definitely other substance is oxidized. See, for this reaction also you can see this Fe2O3, this is iron oxide, this is aluminium, converted into aluminium oxide, and this is what? Iron. So this iron oxide, when aluminium is added to this, it is converted into iron. So no more oxygen is there with the iron. So this is what? Removal of oxygen. And removal of oxygen is what? Yes, it's a reduction. And this is the aluminium. So aluminium converted into Al2O3, that is aluminium oxide. So here the addition of oxygen is called oxidation. So in this way, I think it is clear to all of you what is oxidation and what is reduction. And the combination of this, it is called redox reaction. It is called redox reaction. Okay, fine. So in this there are two more terms are there. First I am going to write down oxidizing agent. Oxidizing agent. Oxidizing agent, it is the agent which itself gets reduced, and helps in oxidation of other substance. Second term is reducing agent. Reducing agent which itself gets oxidized. And helps in reduction of other substance. So let's understand these two terms in these two reactions. Oxidizing agent which itself get reduced. So in this reaction, just tell me, reduction of zinc oxide take place. And this zinc oxide helps carbon to get oxidized. How? See, zinc oxide is the carrier of oxygen and this carbon wants to get oxidized. So supply of the oxygen is done by the zinc oxide. It means that this oxygen is supplied by zinc oxide. So that is why this carbon is oxidized. So it helps carbon to get oxidized. So it itself behaves as a what? It itself get reduced and helps this carbon to get oxidized. So that is why zinc oxide is a oxidizing agent. Just see the reaction which itself get reduced. It is very correct that it is reduced and helps the other substance and helps in the oxidation of other substance. This substance is oxidized. So in the first reaction, oxidizing agent is zinc oxide. I think it's clear to all of you. है ना? So in the above reaction example, oxidizing agent is zinc oxide. Now let's see reducing agent. If you know this, then it will be easy for you to understand what is reducing agent. Itself get oxidized. So here the oxidation of what? Oxidation of carbon take place. So here the carbon is there. It is oxidized. So converted into carbon monoxide. So if it get oxidized means it helps zinc to reduced. If carbon is ready to take the oxygen, it means that it forces zinc oxide to release oxygen. So that is why here the reducing agent which itself get oxidized. So this is getting oxidized. So it is, this carbon is a reducing agent. Now in this example, it's very clear. In this oxidizing agent which itself get reduced. So Fe2O3 is getting reduced. So Fe2O3. In this reaction, what is a reducing agent which itself get oxidized? Aluminium getting oxidized. So aluminium is your reducing agent. So I think it's clear to all of you what is redox reaction and what is oxidizing agent and reducing agent. So we can see so many other examples also. Now let's move to the next topic, is the corrosion. Corrosion. Corrosion, it is the process in which slow eating up of reactive metals takes place. Slow eating up of reactive metals takes place by oxygen, humidity, carbon dioxide or hydrogen sulfide present in atmosphere. Let me explain you once again. Next topic is the corrosion. It is the process in which slow eating up of reactive metals. Important is the reactive metal. Reactive metal take place by oxygen, water vapor or humidity, carbon dioxide or hydrogen sulfide present in the atmosphere. It means that for the reactive metal, all these gases are very harmful. All these gases are very harmful because they are responsible for the corrosion of the reactive metal. Corrosion, it is not a positive process. Actually, it's a negative process. It means that it decreases the life of the metal. Corrosion, it decreases the life of the metal. It decreases the strength of the metal. And very commonly, you might have observed that rusting of iron, rusting of bridges, rusting of machines made up of iron and all that. So it's not a positive process, it's a negative process that it decreases the life of the metal. Fine. So corrosion is clear to all of you. So we will see that, as I said, that for the reactive metal. So it's very common thinking that rusting or the corrosion only takes place with the iron. It is not so. It can happen with so many other metals also. So first we will see how it happens with the iron. So iron, because iron is very common that it is used in so many articles, so many machines in order to make the big bridges, heavy machines. Even for the windows and the doors channels also iron is used. So that is why it is very common in our day-to-day life. So iron, it reacts with oxygen. Oxygen, it has come from air. Oxygen, it has come from air, and water, that is moisture. So when these factors are responsible, these factors which are responsible for the rusting or the corrosion of the iron are available, then this iron, pure iron, is converted into its oxide form. Pure iron is converted into its oxide form, that is Fe2O3, and it is very common during rainy season, and whenever the humidity is more in the air, that time the rate of the rusting of the iron is fast. So because that with this iron oxide, water vapor or the humidity is also associated and the number is not so fixed. So that is why it is written XH2O. So in this way red color rust is formed. The color of the rust is red color. Rust is formed, and this material, it is of the, I can say that rust, I think all of you have seen, it is flaky powder. This I am explaining the physical nature of the rust, and it is non-sticky in nature. Non-sticky in nature. It is in the form of the powder. So when iron is exposed to oxygen that has come from the air, humidity present in the air, it forms the rust, and the formula of the rust Fe2O3.XH2O. Very important, the formula of the rust. We must remember what's the formula of the rust and the chemical formula and chemical name of the rust, that is hydrated ferric oxide. Fine. Now what about the copper? Copper utensils or copper articles, I think all of you have seen that after some, if you are not cleaning it regularly, it comes converted into green color. It is converted into green color. That also comes under the process of the corrosion. So this copper combines with carbon dioxide and oxygen and humidity. Once again, copper combines with carbon dioxide, oxygen and water. All these components are present in air. All these components are present in the air, and it is converted into copper carbonate, copper hydroxide. CuCO3.CuOH whole twice. OH is responsible for the basic nature, so that is why this is called basic copper carbonate. This is called basic copper carbonate, and it is of green color. Remember, basic copper carbonate, it is of green color. So this is the reaction for the rusting of copper. Now the second one is that the silver, that this silver utensils or silver jewelries, you have observed that it turns into black color when it gets oxidized in the air. So here silver, it reacts with hydrogen sulfide. It reacts with H2S, hydrogen sulfide present in the air, and it is converted into Ag2S. Ag2S, this is called silver sulfide. This is called silver sulfide, and what? Here comes out hydrogen gas. So this is also the reaction for the corrosion of the silver. Okay, so here the corrosion topic I explained with the help of the three metals, that is iron, copper and silver. Corrosion process. So this rusting or the corrosion, how we can prevent it? Rusting or the corrosion of any metal can be prevented by what? Painting, greasing, oiling, and especially iron we can prevent it by galvanization. Moving on to the next topic after the corrosion, that how to prevent corrosion, that is methods to prevent corrosion. As I told you, the corrosion, it's a negative process that not favorable for any of the process. Corrosion mainly take place on the reactive metals, as I told you. So big bridges, heavy machines, they are made up of iron. So what happened when the bridges and the window grills or the heavy machine vehicle parts, if we want to prevent, so every year government has to spend lot of money in order to maintain the strength of heavy bridges, in order to paint and all that. So definitely we have to search the latest method or any low cost method to prevent the corrosion. So these are the some methods to prevent the corrosion. Just have a look. The first method is by painting. So yes, by painting the bridges or the vehicles and all that, we can prevent the corrosion. This method, all of you know that at the time of the festival and other time also, yes, we used to paint our window grill, heavy gates and all that. Next one is by greasing. So all the vehicles, in the bicycle also where the chain is there, or in any other door or heavy machine, grease is used. Grease is used to prevent the corrosion. Next method is the galvanization. So just have a look of this galvanization. Galvanization, it is the process in which the coating of zinc is done on the surface of the iron. So for example, any article which is made up of this iron, so on the surface of the iron, the coating of the zinc is done. Coating of the zinc is applied on the surface of the iron. Here in the center, iron is there. And how it works? Actually, what happened that this zinc is more reactive. It is more reactive. Zinc is more reactive than iron. So what happened? This zinc is actually exposed to the atmosphere, as here the iron is present and outer coating it is of the zinc. So zinc is actually exposed to oxygen, carbon dioxide or humidity. Okay. So zinc is exposed to the atmosphere. So what happened? First, zinc sacrifices itself to prevent the attack of all these gases. Okay. So that is why in this way zinc is, as I told you, zinc is more reactive. So it reacts with all these elements present in the atmosphere and it prevents iron from getting rust. So that is why this galvanization as the coating of zinc on the surface of the iron is also called sacrificial method to prevent the corrosion. It is also called the method that is called sacrificial method, in which the zinc sacrifices itself for iron. So this is all about the corrosion. I think it's clear to all of you. Now the next method or the next term we are going to deal in this chapter is the rancidity. Rancidity is very common term what happened in this? Oxidation of oil and fat. Oxidation of oil and fat in a food results in to a bad smell and bad taste. So it's a day-to-day life only that leftover the food items. Okay, if you are not keeping in the refrigerator, what happens to that? Your mama used to throw it away because bad smell comes out and the taste is also very bad and it's not good to consume it. It becomes poisonous in nature, and that is what? Rancidity. So rancidity is the spoiling of the food. Spoiling of the food. And why spoiling of the food? It is due to the presence of oil and fat in the food. And what happens to the oil and the fat present in the food? That actually oxidation of oil and fat, what is present in the food, and because of the oxidation of oil and fat, what happened? A volatile substance is formed. Volatile word I use, volatile means which changes from liquid to gas at a room temperature, and because of that volatile substance bad smell comes out, because smell means it travels through gas. Bad smell comes out and that substance becomes unfit to consume. So that is why bad taste is also there. So this is what called rancidity. So how we can prevent the rancidity? Rancidity can be prevented by adding antioxidant. You see the term anti means anti-social element and all that. You have heard this anti word. Anti means against oxidation. So we have to add some substance which resist oxidation, which can stop the oxidation, which can prevent the oxidation. So in the food we have to add some antioxidant material. Okay. Next one is the antioxidant material, means you can remove the oxygen from the packet, you can add the nitrogen to that packet, that nitrogen prevents the oxidation. Next method is the vacuum packing. Vacuum is what? Nothing is present. Air is also not present, nothing is present. So vacuum packing means completely vacant. Okay, if nothing is present means oxygen is also absent. If oxygen is also absent means rancidity can't take place. Okay? Next, third method is replacing air by nitrogen. In the air, what is present? In the air, oxygen is present. So if you are replacing air by nitrogen. Then what happened? Definitely we can prevent the rancidity. Next method, refrigeration of food. Refrigeration of the food, it's our day-to-day practice. Leftover food item or so many other food item, vegetables and all that, cooked or uncooked food, we used to keep in refrigerator, because what happened in the refrigeration? Temperature is less. Lowering the temperature lowers the rate of oxidation, because for the oxidation little bit energy is required, and that energy is required in the form of the heat. So lowering temperature lowers the oxidation. So we can prevent the rancidity by refrigeration of the food items also. So I think it's clear to all of you. In this video we have covered the topic that is oxidation, reduction, oxidation reaction and reduction reaction. Combination of oxidation and reduction reaction is called, yes, is called redox reaction. After redox reaction and examples of the redox reaction, we have studied in this video reducing agent and oxidizing agent. What are reducing agents and oxidizing agent? Fine. And after this we have covered the topic corrosion. What is corrosion? And the corrosion takes place in few reactive metals like iron, copper, silver. We have seen the with the help of the reaction also. Then next topic I covered in this video, that how to prevent the corrosion, the methods to prevent the corrosion, that we have studied. And the next rancidity we have covered in this topic. In the next video very soon I am going to share the few more examples of redox reaction, because redox reaction or the oxidation reduction, three definitions are there, as I told you, that addition of oxygen, removal of hydrogen, removal of electron and all that. So I have to take more example so that we can cover the three definitions of redox reaction. So thank you.